So today we have another application of derivatives with log. This one is a bit more complicated. So we're asked to find a and b in the equation y equals x to the power a ln b to the x, b times x at the critical point 1 and 2. Alright, so first things first. By critical point, we know that it actually means when the derivative of y is equal to 0. So that means we gotta differentiate this. So using product rule, since we have two x components, we get y prime equals a to the power x minus 1, a minus 1, power rule, times ln bx plus a x to the power a, and then times derivative of ln bx, which is 1 over bx, times b, because of chain rule. Alright, so we know this and this cancels out, so we can rewrite this whole entire thing to be y prime equals a to the power x to the power a times x to the power of a minus 1 ln bx plus x to the power, x to the power a minus 1, because we know that 1 over x is equal to x minus 1. Right, so we have a factor here that we can factor out. So we get y prime equals x to the power a minus 1 times a ln bx plus 1. Alright, so we know that we got to get y prime equal to 0 at x equals 1, according to this critical point. So let's plug both of those in. 0 times 1, but 1 to the power of anything is just 1. So really, we get 1 times a ln b plus 1. Right, and that really is just a ln b equals minus 1. So ln b equals negative 1 divided by a, and b equals e to the power of negative 1 divided by a. So now we know our b value. Well, our complex b value, we still have to find what a is. So, what's that? So when we get one of these equations that ask us to find a critical point, you have to remember that this point is also on the actual graph. So you can actually plug that back in. So 2 equals 1 to the power a, then ln times b. And make this clear, it's 2. And so that easily simplifies to 2 equals ln b, and we know b is equal to this. So just by plugging that in, we get 2 equals ln e to the power negative 1 over a. That just simplifies to 2 equals negative 1 over a. And so a equals negative 1 half. Right. So we can just plug that back into b. Right, this is our b value, which we got from evaluating it at the evaluating the derivative at the critical point. And so we substitute our a value, e to the power negative 1, negative 1 over 2, parentheses. And so b equals e to the power of 2. And that is our final answer. Not that complicated. When solving these types of problems, all you have to really do is remember that when you have a critical point, you can understand that in 2 ways. One, at that x value, the derivative must be equal to 0, but 2, that point also exists on the graph, so you can use that to evaluate the expression. Alright, thank you for watching.